two-dimensional computer screens for virtual learning to three-dimensional virtual reality experiences, it seems only fitting that a first micro lecture would be exploring multiple dimensions. So I've got on the board here some different examples of dimensions. So we have a zero-dimensional point, a one-dimensional line segment, two-dimensional square, and drawn on a two-dimensional board, we have a three-dimensional cube. Okay? So how do we get from one to the other? Okay? Well, we start with a point, and in one dimension, what you can do is think about extending that point. You have your point, extending it out to another point to where you end up with your line segment. Okay, so how do you get from a line segment to a square? Well, you still think about starting out with a line segment. We're going to extend that out to another line segment. And when you extend it out in the second dimension, you end up precisely with a square. How do we get from the square to the cube? Okay, let's move beyond the two-dimensional board. Got some squares here. We've got one square. We're going to extend it to another square. And when you do that extension, we have to connect these pieces. So just like when we went from the line segment to the square, okay, we took our line segments and connected them with other line segments to get the square. When we extend from a square to a second square, then we need to connect those faces by squares. Okay. So you end up then with two squares that are all sides connected by squares. So we can move from one dimension to the next just by extending an object and connecting all of its sides, okay, with more of those objects. So when we went from the line to the square, we extended it and connected it by lines. When we went from the square to the cube, we extended that square and connected all of the sides by more squares. So what would it look like to extend from the three-dimensional cube to the four-dimensional hypercube or tesseract? Okay, well, somehow we need to take our cube, extend it to another cube, and connect all of the sides by cubes. So we're looking here for what would a hypercube look like? So imagine cube, extending it to another cube, but somehow we need to connect all of the sides together with cubes. Okay, well, let's think about what the sides are on this cube, the faces. So somehow we need to build off this face with a cube. We need to build off this face with a cube. Every single face we build off of with a number cube, and when you do that, think about this bottom face, this face, these faces that we're creating. All of those extra faces come together to give us a hypercube. So if we would draw what a hypercube might look like, you've got the cube that you start with, and then you have that second cube you've extended it to. But I'm living in a three-dimensional world here, so using my imagination, what that's going to have to do is be a cube within a larger cube so that I can get all of the faces to connect appropriately. So here's the first face of my larger cube. I'm going to extend it to the front face of that cube. Now I'll do the back cube, okay, behind this object, and I'm going to extend that to this back face of my inner cube. So connecting those together. Okay. And then we've got those. And then what you have on the sides are just, we've already got the faces, we just need to connect